The modeling of volumetric objects with distinct structures and smooth and sharp color transitions is still a difficult problem in graphics. In this paper, we introduce a new representation called Diffusion Surfaces to enable modeling of such objects. Our contributions are, first, the diffusion surfaces representation and an efficient algorithm for computing color diffusions, and second, a user interface for creating diffusion surfaces, which can synthesize random variations of models. Diffusion surfaces are defined as standard triangular surface meshes, where each mesh vertex has colors on both front and back sides. When the user cuts the model, a cross-sectional mesh is generated, and consistent volumetric colors are computed on the cross-section. We employ positive mean value coordinates to achieve this, which does not require any voxel grids or tetrahedral meshes, and is well suited for interactive modeling. Please refer to the paper for more details. Diffusion surfaces can be used to model arbitrary volumetric objects, but here we focus on modeling of objects with rotational symmetry, as a case study of designing user interfaces. We consider two types of rotational symmetry: cylindrical symmetry and n-fold symmetry. For the case of cylindrical symmetry, the user first draws curves on an image of a vertical cross-section, then draws curves on an image of a horizontal cross-section, and finally the system generates 3D surfaces by sweeping. For the case of n-fold symmetry, we consider two types of geometries: type 1 that surrounds the axis, and type 2 that are within each fold. For the type 1 geometry, the process is the same as in the case of cylindrical symmetry, except that the user needs to specify the number of folds and adjust the fold angles. For the type 2 geometry, the user sketches a closed loop on the vertical cross-section, and then sketches n closed loops on the horizontal cross-section. Finally, the system generates 3D surfaces by sweeping. An advantage of our symmetry-aware interface is that it can synthesize random variations of models. The number of folds can also be changed. This feature is useful, especially for creating scenes with many similar but not identical objects. The user can cut the model at arbitrary locations interactively by drawing free-form strokes. We are able to create numerous diffusion surfaces models using our interface. Because photorealistic rendering of cross-sections of diffusion surfaces is still difficult, we apply simple non-photorealistic rendering techniques to increase the expressivity of plain color rendering. The diffusion surfaces representation can be used for a variety of volumetric structures, such as fruit, vegetables, geological models, and anatomical models. Here are scenes consisting of many cut pieces of objects, where our algorithm for synthesizing random variations of models is very effective. Thank you for your time.